Welcome back to the deep dive. Today, we are really getting into the weeds. We're going deep on the foundational architecture of the software-defined data center, specifically VMware Cloud Foundation, or VCF.
Yeah, we've sifted through a whole lot of materials, some advanced training stuff, certification prep, basically distilled it down to what you really need to know operationally.
That's the plan. Our mission here isn't to test you. Think of this as your shortcut. Instead of wading through, tons of documentation, we're zeroing in on the critical control points, the little prerequisites that can completely derail things, and the core management ideas behind running a big VCF setup.
Exactly. The sources hit everything from initial design to day two ops. But we're going to focus on the absolute non-negotiables. Things like network requirements that can be, silent killers if you miss them.
Right.
And the roles of key services like VLCM, how VCF handles complexity. Really, the big takeaway from all this is how centralized the control is in VCF.
Okay, let's unpack that, starting right at square one. A brand new deployment, you've got your hardware racked up, you're all set to use the Cloud Builder appliance for that automated install. Before you actually hit go on that whole process, what's the single most vital network service? The one that has to be working perfectly?
It's got to be DNS, Domain Name System Configuration. That's the absolute must-have.
DNS. Okay, that sounds almost basic. We kind of take it for granted, don't we? But why specifically in this automated VCF deployment is getting DNS wrong such a showstopper? Why does it break everything?
Well, it really boils down to identity and trust, which, is fundamental for any kind of automation. VCF isn't something you install by hand, clicking through wizards for every component.
Right, it's automated.
Totally. So the Cloud Builder and then later the SDDC Manager, that's the main brain, they need to find everything by name, not just IP address. They're looking for ESXi hosts, vCenter, the NSX Manager.
Oh, my host name?
All by host name. And crucially, the system uses those names when it generates and issues all the internal security certificates, for secure communication between all the parts.
Oh.
So if it can't resolve a host name reliably, boom, certificate issuance fails, and the automation just grinds to a halt. It can't build those secure connections without knowing who it's talking to, essentially.
Right.
Without that verified identity.
So it's not just for us humans to keep track of things easier. It's baked into the security, the trust model between all the automated components. That makes a lot of sense why it's so critical.
Exactly right. And it's often a silent killer because, admins might check basic ping connectivity, but they miss a subtle issue. Like maybe forward lookups work, but reverse lookups don't, or vice versa.
Got it. Okay, so DNS is working, name resolution is happy. Now let's talk hardware. We physically put new ESXi hosts in the racks, cabled them up, they're powered on, ready to go. What's the step we have to take using the VCF tools to make these raw machines actually usable, to get them ready for, say, a new workload domain?
All right, so once they're physically in place, the administrator needs to use the SDDC Manager, that central hub, again, to first discover these hosts and then commission them.
Discover and commission. Tell me a bit more about that. Why is that specific step needed? Why can't we just, add them directly in vCenter like we might normally do?
Because VCF isn't just a random collection of hosts. It's a validated, integrated system. Commissioning isn't just finding the hosts on the network. It's actually a compliance check. SDDC Manager checks. Does this hardware actually match the official VCF bill of materials? Are the network settings correct? Is the firmware level compatible? It's basically validating that the host meets all the requirements before it's allowed into the managed environment. It's the gatekeepers ensuring that architectural standard is maintained.
That flows perfectly into talking more about the SDDC Manager itself, because it sounds like it's way more than just a deployment tool. This is where it gets really interesting, right? How does it function as that central brain day to day? How does it keep potentially hundreds of ESXi hosts across different domains all healthy and compliant?
Yeah, it is the central brain. And it does that by working really closely with the underlying services, especially VSAN for the storage side, and critically, vSphere Lifecycle Manager, or VLCM. That integration is absolutely key for ongoing operations.
Let's zoom in on VLCM for a sec. In traditional setups, you always battle configuration drift, right? Hosts slowly get out of sync with patches, drivers, firmware. It causes instability. How does SDDC Manager use VLCM to basically kill that problem in VCF?
It flips the model, really. Instead of chasing drift, it enforces consistency. SDDC Manager maintains what's called a desired state image. Think of it as a single perfect blueprint software, drivers, firmware for all the ESXs in a given workload domain.
Okay, one golden image.
Exactly. And VLCM is the engine that enforces that image. So instead of you manually patching host A, then host B, hoping they match, SDDC Manager orchestrates VLCM to apply updates based on that image. It ensures every single host stays locked to that standard, massively cuts down operational work, and crucially, shrinks the security attack surface from having out-of-date stuff.
That centralized control must also simplify security management, which can be a real headache otherwise. I know the SDDC Manager has this thing called the locker service. When you hear locker service, what's the main security job it's handling?
Certificates. Specifically, managing the lifecycle of internal certificates. It securely stores credentials too, but the big ongoing task is dealing with all the certificates used for communication between VCF components.
Right, certificates expire. Why is automating the renewal of those certs so important in a VCF environment? Maybe more so than in less integrated setups.
Because everything talks to everything else. You've got NSX managers, vCenter, VSAN, SDDC manager components. They all rely on secure, certificate-based communication. If just one certificate expires somewhere in that chain,
Communications break down.
exactly, you can suddenly find critical services can't talk to each other. Operations just stop. It's a super common and really painful admin mistake in traditional environments. The locker service automates that renewal process and makes sure those internal certs get replaced before they expire, keeping everything communicating securely without someone having to manually track hundreds of certs. It treats them as ephemeral, which is really the modern way to handle it.
Yeah, that sounds crucial for maintaining stability at scale.
Okay, staying with scale. If I'm an admin and I need to do something big and repetitive, let's say, deploy 10 identical workload domains over the next quarter, why might using the GUI, the graphical interface, not be the best approach?
Yeah.
And what is the recommended way for that kind of large-scale programmatic automation?
For anything you need to do repeatedly, reliably, at scale, the answer is the SDDC Manager REST API. The API. No, wait, the GUI works fine, doesn't it? Why push people towards the API for something like deploying domains?
The GUI is great for visibility, for monitoring, for maybe doing a one-off task. But when you need to do the same thing multiple times, precisely the same way, the GUI relies on human clicks. And humans, well, we make mistakes. We forget a checkbox. We type something slightly differently.
Introduces variability.
Exactly. The API gives you programmatic control. You can use scripting tools, Python, PowerShell, or automation frameworks like Ansible or Terraform to call the API. You define the deployment once in code, and then you can run that code 10 times, 100 times, and know you're getting the exact same result every single time. It gives you idempotency and consistency, which is really the whole point of VCF standardization. The API is built for that level of automation.
Okay, that makes perfect sense. Let's shift gears a bit to operations, keeping things running, and what happens when inevitably something goes wrong. We need a good triage process. VCF relies on lifecycle management, LCM, for those updates we talked about, so scenario. An admin tries to apply an update bundle using LCM, and it fails. What's the absolute first thing they should do? The smartest first step before just trying again or rebooting things?
Resist the urge to just hit retry or manually fiddle. The first and usually most effective step is to check the SDDC Manager pre-check logs for that specific update task.
The pre-check logs, but the upgrade failed, not the pre-check. Why look there?
Because the pre-check is designed to catch problems before the actual installation or upgrade starts.
Yeah.
It checks dependencies, connectivity, disk space versions, all the prerequisites. If the upgrade itself failed, it often means either a problem flagged by the pre-check wasn't fixed, or some prerequisite issue caused the failure during the main process. Those pre-check logs are incredibly detailed. They'll usually point directly to the root cause. Can't reach host X, DNS resolution failed for component Y, insufficient space on Z. You find the specific reason in the logs, fix that, and then the retry is much more likely to succeed. It saves a ton of guesswork and avoids making things worse.
Excellent operational advice. Okay, different problem, performance. Let's say you're seeing sluggishness on a vSAN data store. Seems like a storage bottleneck. Where's the best place to go within the VCF tools to get detailed real-time vSAN metrics, things like IOPS, latency, throughput, correlated across the whole cluster?
For deep vSAN performance analysis, your primary tool is the vCenter vSAN Performance Monitoring Service.
Why that specifically? Couldn't I just look at performance counters on the individual ESXi hosts?
You could, but vSAN isn't just local disk performance, right? It's a distributed storage system. A bottleneck might be caused by network latency between hosts, or specific types of I/O overwhelming one part of the distributed system. Looking at individual host counters doesn't give you that complete picture.
Got it.
The vCenter vSAN Performance Service is built specifically for this. It aggregates metrics from all the hosts participating in vSAN, understands the vSAN architecture, and lets you slice and dice the data, look at latency versus IOPS, break down read versus write performance, see front-end versus back-end metrics. It gives you the context you need to actually diagnose a distributed storage issue, which standard host metrics just don't provide as clearly.
Makes sense. One more troubleshooting angle. Sometimes you need to get really deep, maybe pull specific logs directly off an appliance. If an admin needs secure command line access, direct CLI access to the SDDC manager appliance itself, what's the standard recommended way to do that?
That would be using SSH Secure Shell. Connecting with the designated administrator credentials, usually the VCF user, or similar. It gives you controlled, direct access right into the appliance's operating system for those really advanced troubleshooting or log gathering tasks when the GI or API just aren't enough.
Okay, good to know. Let's wrap up by looking at a couple of key architectural pieces that handle specific jobs. First, routing. Getting traffic in and out of the whole VCF environment, north-south traffic. Where does the main component for that, the Tier 0 gateway, usually live in a VCF design, and why is that placement important?
Right, the Tier 0 gateway, that's the big router connecting your software-defined network, your NSX overlay, to the physical network outside. In a standard VCF architecture, this is deployed within a dedicated VCF construct called an edge workload domain.
An edge workload domain. Why create a whole separate domain just for these edge routing services?
It's mainly about isolation and resource management.
Edge
Services, the Tier 0 routers, maybe Tier 1s, load balancers, firewalls running on NSX edge appliances.
Yeah.
They can have very different performance demands and security postures compared to your regular application workloads.
Sure.
By putting them in their own dedicated cluster, their own workload domain, you isolate their resource needs, CPU, memory, network bandwidth for routing, from your application VMs. It also creates a really clear security boundary and simplifies management. You scale your edge resources independently from your compute resources. It's a core VCF design principle for scalability and resilience.
Okay, architecture matters. Last piece, mobility. Infrastructure isn't usually stuck in one building anymore. You often have multiple VCF instances, maybe across different sites for disaster recovery or migration purposes. What's the go-to VMware solution that integrates smoothly with VCF for moving VMs between sites, handling DR, network extension, that kind of thing?
The solution designed specifically for that kind of hybrid cloud connectivity and mobility with VCF is VMware HCX.
HCX. It always feels a bit like magic. For someone listening, what's the biggest, most painful problem HCX solves when you need to move VMs between, say, two different VCF data centers?
The IP address nightmare. That's the big one it tackles. Traditionally, if you move a VM from site A to site B, they're usually on different network subnets, right? So you had to change the VM's IP address.
Right.
Which might mean reconfiguring the application, updating DNS. It's a huge pain, especially for lots of VMs.
Oh yeah, re-IPing is awful.
HCX has this capability called network extension. It can essentially stretch your layer 2 network segment from site A over the WAN connection to site B. It creates a tunnel. This means you can migrate a VM from A to B, and it keeps its original IP address. It thinks it's still on the same network. This makes disaster recovery failover so much easier and allows for massive bulk migrations without needing to touch the networking inside hundreds of VMs. It's pretty indispensable for VCF mobility between sites.
Thank you for joining us on this deep dive into VMware Cloud Foundation architecture. We really hope this gave you that shortcut, that clarity on the operational essentials.